Hello and welcome to this presentation. My name is Majid from Nokia as a senior cloud engineer. In this presentation, I'm going to talk about the federated machine learning plugin of the UPCAST project. Here is the agenda after today's presentation. I will talk a bit of short description about the tool or plugin and then why it matters for the SMEs, some analysis of the plugin, and then we would have a short demo of the federated machine learning plugin. Just to have an introduction about the federated learning. Federated learning, also referred as collaborative learning, is a decentralized approach for training machine learning models. It doesn't require an exchange of data between client devices to the global servers or other clients. Instead, the raw data would stays on the edge device on the client environment will be used to train the model, and then a server will do the orchestration. It will increase data privacy, and the final model which is a kind of result of the collaborative learning between different clients, would be shared with the user or end user who has requested it. Why this federated machine learning matters for the SMEs? There are four different topics which matters for the SMEs because of this federated machine learning. One is the data privacy. Federated machine learning enables model training on sensitive data or regulated data without centralized data collection, which preserves the privacy. Second, federated machine learning would reduce the data transfer. As the data would stays on the client side, it minimizes the need to move large amount of data sets between clients or servers, which would eventually save the bandwidth and also reduce the latency. Third, federated machine learning would enable decentralized learning. It will allow training on geographically distributed data sources, and it's very ideal for the edge computing scenarios. Imagine there are different clients that hold separate data sets, and they are located on different locations around the world, and the federated machine learning would enable to this federated learning scenarios very easily. Fourth is that the federated machine learning would enable for the clients to avoid any regulatory issues. As there are many countries which have some regulatory issues that certain data cannot leave the country, this federated machine learning would help the clients to meet these data localization requirements by keeping the data on local devices or within specific jurisdictions. If I want to talk about this federated machine learning plugin itself, as I mentioned, this federated machine learning plugin enables the data providers and consumers to participate in a federated learning scenario without the need of transferring their data to client or even third-party stakeholders. Clients who owns a machine learning model would utilize this plugin. So they upload the model, they have an initial model, which they want to be trained on a certain data. Then the plugin orchestrates the federated learning scenario by uploading the model weight and variables, certain requirements, whatever needed for the model to be trained locally, to the clients who owns the data. And then the client who owns the data would train the model on the data locally and send back the new variables to the orchestrator. Then the orchestrator depends on the configuration which has been set by the initial client, would aggregate all the results. There are different aggregation strategies, And based on the configuration, it may repeat this sending to the model variable to the clients with the data multiple times, so to increase the accuracy and improve the model. Once it's done, then the final trained aggregated model would be handed over to the client who owns the initial model. This plugin, because of the specific structure, has two main components. It's not just one component. One is a server application that would be run on the main server or inside the data marketplace, depends on the scenario and depends on the environment which this needs to be run. And it will act as an orchestrator or an aggregator for the federated machine learning project. Then we have a client app which needs to be installed on the clients with the data that can act as an agent of this federated machine learning and would train the data locally and then has the possibility to send back and work with the federated machine learning server app side to aggregate and work this federated machine learning scenario. Because of the specific structure of the federated machine learning, the server and the clients should be able to communicate with each other. So there's certain environmental requirements for the connectivity, IP, public IPs, and ports need to be aligned between the server and the data provider. Now we would have a short demo of the federated machine learning plugin.
Before showing the demo of the actual plugin, it's better to go through the steps and the sequence of the actions which is going to take place while we are running a federated machine learning scenario. As it's been described in the document, in a federated machine learning, the clients, or let's say the data providers which provide the data, they do not share or transfer the data, locally stored data, to any server or to the data consumer. So the data stays as it is on the clients, and the data consumer, which practically has a model which it needs to be trained on the local data on those clients, share the model with the server, which is acting as a aggregator and orchestrator on top of the clients, and then the server distribute the model variables and parameters to the clients, and then the clients doing the training locally on the data sets, and then depend on the number of rounds which has been requested for the training. On each round, the clients will just send the model updates which has been trained on the local data to the server, and then server aggregate all those model parameters to one global model. Depend on the strategy, we have different strategy, but let's say federated averaging on top of all those models. And then the next round, depending on the number of rounds which are required, will be started again. So the new updated model will be distributed among the clients, and then the clients will will again run the locally training on this new updated model, and then they send back again the parameters. And these steps will be repeated, depends on the number of rounds which are required. At the end, the final model will be aggregated and ready by the server, and then the final model can be transferred to the data consumer. So now let's start the plugin. So as it's been mentioned, also there's a GUI, but the functions also available via API. So first of all, the data consumer should set up the federated machine learning scenario. So it describes how many rounds required, what strategy needs to be selected for the aggregating, and then how many minimum number of clients to be participated in its training, because the data could be stored, for example, on 5 different clients, and they want to participate on the federated machine learning, but for any reason 1 or 2 clients, for example, cannot participate at that time. So, or it's been required for example, at least 2 clients should be sending their updated model, and then the IPs of the clients will be added, and the ports, because the client should be communicating with the server. So this needs to be required, and if there is any firewall or limitation in place, this should be configured so that they could be able to communicate with the server. Once it's been set up, then we need to run the federated. We can run the federated machine learning. So in this step, the data consumer, which intends to train its own model locally on the client's data sets, need to upload the initial model and upload it to the server so it can be trained locally on the client's data. Once it's been uploaded, then the data consumer select the setup which has been set up in the previous step, and then start the training. So this will initiate the training on the server side. The clients should be available, and they have to have the client's application also ready and running on their sites, because this is a bit of collaboration between the clients and the server. So they need to be in contact, and this should be running on the clients. As you see from the logs also, you can see that the clients and the server start communicating, and the clients receive the initial model and start fitting and trained locally on their own data set. This will, as I mentioned in the sequence diagram, this will be repeated based on the number of requested rounds. For example, in this setup, we have 3 rounds. This will be happening, and then each round a new training will happen locally on the data sets. On each round, we can also see if it's an secure, unencrypted way of training, because the other one which takes a bit of lengthy time. So we see that each round will send the bias, the value, and the updated model for each round printed on the server side. At the end, we can see the final model that can be uploaded to the data consumer. At the end, as you can see, the model has been, the training has been finished, and the final model is now stored, so it can be transferred to the data consumer through the data marketplace, any marketplace which using this plugin through its means. Thank you.